Hey guys, we're back. Moving on. Pythagorean theorem and space figures. Space figures? You mean like aliens? Oh wow. Ooh. All right. Do me a solid. Okay, let's talk about three-dimensional figures are called geometric solids. And what we have here is called a rectangular solid. So we have a number of issues or a number of things with rectangular solids that we'd like to discuss. So one of them is the number of sides, or what we call faces, and there'd be 1, 2, so the right and left side, 3, 4, that's top and bottom, and then I'll do these, the front and back would be 5, and then 6 in the back. So those are all the faces of a rectangular solid. A segment AB is one of 12 edges. Each of those segments that forms an edge. So AB and then BC and then AD. So let's do a little highlighting with that. So these would be the edges. Okay, where each of the faces meets, that's an edge. Okay. Next, we'd have one of 4 diagonals. So here would be 1. You'll notice this starts up at here at the top and finishes at the bottom corner. That's a diagonal of a rectangular solid. So they kind of crisscross through the solid. All right, do me another solid. Okay, this is called a regular square pyramid. And in the regular square pyramid, the base, JKMO, that's a square, it's called the base. Point P is the vertex. The difference between rectangular solids and pyramids is that rectangular solids, the faces are rectangles. And in a pyramid solid, there are 4 or however many, depending upon the base, sides, we'll call that, that are triangles. Okay, so those faces are triangles versus rectangles or squares. So JKMO, that's this base, this is the base down here. Okay, it's the only shape that's part of the solid that's not a triangle. Point P is the vertex, so that would be the very top of it. So segment PR is this segment that drops from the vertex down. So imagine if you had a piece of string with a stone on it or whatever at the top of the pyramid, and you were able to drop it straight down into the base. Okay, that would be the altitude. Now the slant height is this distance down the face. So if we have this distance right here that goes down the face, and you'll see it is a perpendicular line from the vertex down the face of triangle PKM, and it is perpendicular to segment KM. Well, excuse me. So cube is a rectangular solid in which all edges are congruent, right? And each of the faces are congruent, right? They're all squares. So that's what a cube is. It's a rectangular solid which all 6 sides are squares that are congruent to each other. Okay, let's insert some example problems here. So the diagonals of a rectangular solid are 3, 5, and 7. We want to find the diagonal. So the first thing you're going to have to do is we're going to have to find 2 diagonals, actually. Well, number 1, you're going to have to find this segment first. And then you're going to have to find this segment here. So let's go ahead and do that. First segment we're going to find, as I said, is segment DB. So this is a right angle here because it is rectangular. Therefore, DB is the hypotenuse. So we would have 3 squared plus 7 squared equals DB squared, right? So 9 plus 49 equals DB squared. 9 plus 49 is 58, is equal to DB squared. So therefore DB is equal to the square root of 58. Now, you can go ahead and reduce that if you wish. I don't see any need to. Now, if GC is 5, then HD is also 5. So this is the square root of 58. So now HB is going to be the hypotenuse of this triangle. So we can say that 5 squared plus the square root of 58, and we're going to square that, is equal to HB squared. So 25 plus 58 equals HB squared. So 25 and 58 is 83, right, is equal to HB squared. Therefore, HB is equal to the square root of 83. And that's our final answer. Okay, given the regular square pyramid shown with altitude of segment PR and slant height of PS, perimeter is of JKMO is 40, PK is 13. So find AJK. Well, if the whole perimeter is 40, then JK is 1/4 of that, so JK is going to equal 10. Now, PS we want to find. So, what we can do from that, we are told that PK is 13. So I'm going to write that in, I'll put that in red here. So this distance here is 13. I know that if this is 10, KS has to be 5, right? So we know then that PS is going to be 12, because that's going to be a 5, 12, 13. So the slant height of PS is going to be equal to 12. So the last thing we want to consider is PR. Well, if we go back over here, so if we go back to our information that we already know, and we take a look at this. So if this is 10, we know that this whole distance is also going to be 10, and R is going to split that distance evenly. So that's going to be 5. And we've already learned that the slant height of PS is 12. So therefore we can ascertain that. Now, keeping this in, now we've got to use Pythagorean theorem. We can't assume that we have a Pythagorean triple here. So this is going to be PR squared. So PR squared plus 5 squared equals 12 squared. So PR squared, PR squared, let's erase that and start over. PR squared plus 25 equals 144. So I'm going to subtract 144 from each side of this here, and I've got PR squared is equal to 119. So we take the square root of each side. PR is equal to the square root of 119, and that is a irrational value, so we'll just leave it at that. With all this information I'm throwing at you guys, this next test is going to be like this.
Holy shit.
Exactly.
That's all, folks.
Study hard, boys.